Assalamualaikum and good day. My presentation today is Enhancing Conceptual Understanding of Substitution Reaction Mechanism in Organic Chemistry through O-CHEM Mega 5E VARK module. Mastery of the reaction mechanism is not just about the passing exam. It's the cornerstone of the understanding organic chemistry. As a researchers like a Crandall 2020 have noted, this mechanism formed the backbone of the advanced chemical study. And also for the SUBSTITUTION 2021, he said that create a solid foundation for learning organic chemistry by mastering reaction mechanism. Successful and organic chemistry depend on understanding reaction mechanism. And also for the other researchers previous study, so why are so many students still struggling? Let's find out. This is a type of reaction mechanism in organic chemistry that student needs to cover up. Today, we are diving into critical aspect of organic chemistry that often leave student puzzled: reaction mechanism. The key problem here is difficulties in understanding substitution reaction mechanism in organic chemistry. But we are not just discussing the problem, we are unveiling a breakthrough approach that could redefine how we teach this complex concept. Students actually have the problems in lack of understanding of fundamental idea, the incorrect use of arrow, could not describe the movement of electrons, could not draw the product form, and struggle to distinguish between nucleophile and base. And after that, students struggle with the following sequence of events in the reaction: how to draw to write the overall reaction mechanism. From the problem background, which is student problem in substitution reaction mechanism, the abstractness of the organic chemistry itself, the need for the visualization in substitution reaction mechanism, and inquiry-based learning 5E enhance student conceptual understanding, and integrating VARK learning style. So this solution integration of the 5E inquiry model with the VARK learning style through the O-CHEM Mega 5E VARK model. This is the list of the literature review for the complex and abstract chemical learning, organic chemistry substitution reaction mechanism. While this is a literature review for the inquiry-based learning 5E model and VARK learning model. As I mentioned just now, from the student's problem and for the literature review, the benefit of the VARK learning style, and also for the inquiry 5E, this is actually have a limitation or gap for my research. First, lack of specificity in chemistry education. Current instructional approach are not optimized for addressing diverse students' need in organic chemistry. Second, theoretical emphasis without practical implementation. Literature highlights the theoretical benefit of combining learning style with the instructional model, but lacks practical strategies of educator to apply them effectively. The third one, insufficient integration. Study have focused on VARK or 5E individually, but the combined effect of this model on improving conceptual understanding is not empirically validated. So for the next, my study will be continued about that. My research objective is to design and develop the O-CHEM Mega 5E VARK module to draw the movement of electron represented by the direction of the arrow, draw the reaction products and the reaction mechanism correctly, and after that write the reaction mechanism of the substitution reaction accurately. So my research question is how to develop the O-CHEM Mega 5E VARK module represented by this objective using ADI model. The second one, to test the effectiveness of O-CHEM Mega 5E VARK module in helping students to understand substitution reaction mechanism based on usage of arrow, predicting the reaction products, and writing complete and correct reaction mechanism. Is there any significant differences in student conceptual understanding before and after intervention of O-CHEM MECA 5E VAK model? So this is application in quasi-experiment single group and also for focus group discussion interview. For the conceptual framework, the integration of the constructivism pedagogy with the inquiry-based learning IBL 5E stages while accommodating the diverse VARK learning style provide a comprehensive and effective educational approach. The synthesis allows for the nuanced understanding on how these components work together to enhance the learning experience. This is the detail for the concept and framework, constructivism in inquiry 5E stage for the teaching approach, VARK learning style, and key components. For the research methodology, for the research design, we use a descriptive study, ID model, analysis, design, develop implementation and evaluation, and also the quasi-experimental single group design and focus group discussion, FGD. One single group from the Malacca matriculation students, 1-year program taking organic chemistry 2 for the SK025 subject. Students in group were purposely selected and group were assigned to the purposely sampling, which is 30 students. For the research procedure, for the analysis to analyze the need and main features for newly developed module from the survey, and for design, main features for module was designed in the prototype, and for the module was developed based on the prototype, which is expert validation. And for the implementation, we have pilot study for the reliability, test the effectiveness for the quasi-experiment pre-post one group, and last one is summative evaluation, test score pre-post one group with a conceptual understanding task pre and post, and also from the focus group discussion interview. This is for the research procedure development. Module O-CHEM MECA 5E VARK module consists of video animation, physical toolkit, user guide, notes, worksheet challenge, activity 5E VARK, and also provided lesson plan. This is the proven for the research implementation phase by phase using the conceptual framework. Data collection involves a purposely sampling method with the same group of students for both pre and post test. The analysis aims to be determine the effectiveness of the educational intervention. The pre-test result serve a baseline to identify the students' understanding substitution reaction mechanism, while the post-test result measure the impact of the O-CHEM MECA 5E VARK module. A graph representing the overall mastering of the conceptual understanding. It illustrates the progress student from the pre-test to the post-test, highlighting a significant increase in the knowledge of the substitution reaction mechanism. For example, student 1 increased their score for 85 points, moving from 15 in the pre-test to a perfect 100 in the post-test. Similarly, student 19 improved by 50 points, further confirming the module success in the solidifying their knowledge. For the comparison category of student pre-test and post-test, for students to draw the curve arrow. Before the intervention, nearly half of the students, or 46.6%, were in the weak category, indicating a lack of understanding of substitution reactions. After the intervention, 76.6% of students achieved excellent score, and no student remain in the weak category. This shift shows how effective O-CHEM MECA 5E VARK module as a bridge knowledge gaps and enhance student conceptual understanding of complex organic chemistry concepts. The bar chart illustrating the impact of the O-CHEM Mecca 5 EVR module on student performance. It compares the percentage of students in the weak, moderate, and excellent categories before and after the module's implementation. So the significant improvement, especially the shift from the weak to excellent category, is very big gap. So the module is proven as effective. Table present descriptive statistics that further reinforce this result. The mean pretest score was 31.30 with a wide standard deviation of 19.94, showing a generally low understanding before the intervention. In contrast, the post-test mean score jumped to 97.67 with a much smaller standard deviation of 2.412. This proven that module effective. In table, we conducted tests of normality using both the Kolmogorov and the Shapiro-Wilk test. Although the Shapiro-Wilk test indicates some deviation from the normality, the overall data trends reveal that O-CHEM Mecca 5 EVR module significantly improves student conceptual understanding. To further validate this finding, we performed the Wilcoxon sign rank test. The result confirmed a statistically significant improvement in student post-test score with a p-value of 0.00. All 30 students show a positive rank improvement, highlighting the module's effectiveness in students' performance. Figure visually capture the student's answer before and after the intervention specifically for free radical substitution reaction. This clear progression from low test score to consistently high post-test score emphasize the module's role in fostering a deeper understanding of the subject matter. This is a research finding for the focus group discussion interview. So this table is alignment of interview scope, code, and themes. The research presented today support the several key hypotheses regarding the effectiveness of the O-CHEM Mecca 5 EVARK module in enhancing student understanding reaction mechanism. Our study confirms that the module significantly improves student conceptual grasp of this mechanism. This is shown through the marked improvement in the way students understand, predict, and represent electron flow in the substitution reaction, addressing issues commonly faced with the arrow notation and reaction prediction. This study involved 30 students from the matriculation college and employed a quantitative quasi-experiment approach. Pre-test and post-test results clearly indicate substantial improvement. So the percentage of the students achieving in A grade skyrocketed from the 13.33% to 90%, while the lower grade like C, D, and F were completely eliminated. This speaks to the module success in enhancing conceptual understanding, improving student ability to predict reaction products, and facilitating the construction of complete and correct reaction mechanism. Between the group interviews for the further reinforce this finding with the student consistently reporting high levels of engagement and satisfaction. This highlight the module use of visual aids and hands-on activity as a crucial in enhancing their understanding and retention of complex concepts. Collaborative learning was also a major factor in their academic process. Students appreciated how the module made difficult topics more accessible through the interactive learning, confirming its value beyond the academic performance. And when we look at the finding align with the prior research that emphasize the benefit of interactive tools in chemistry education. However, this study also introduced a new understanding Combining visual aid with the hands-on activity provide a more comprehensive learning experience that focusing on their method alone, as previous study often suggested by Brown and Taylor 2019 and White 2021. The notable improvement in student performance, especially the elimination of the lower grade, mirrors result reported by Adam and Green 2020, reinforcing the important and structured digital learning module. For the implication of this study are far-reaching. The O-CHEM Mega 5 EVARK module demonstrates how interactive and structured digital tools can significantly enhance learning outcomes in organic chemistry for the educators and curriculum developers. This research suggests that need to integrate more interactive elements and hands-on activity into the teaching material. Modules like this can foster deeper conceptual understanding and increase student engagement and motivation. Based on this finding, we recommend several avenues of future research and implementation. First, further study should explore the long-term retention of knowledge required through the module. Second, understanding its lasting impact could provide insight into its potential for sustained learning improvement. The development of additional module targeting other complex chemistry topics would create a comprehensive toolkit to support students across the various areas of curriculum. And finally, expanding the sample size and diversity of future study would give us a broader understanding on how the modules perform across the different student population, allowing for more generalizable conclusion. As to conclude, the O-CHEM Makeup 5 EVARK module has proven to be an effective educational tool that enhances student conceptual understanding of substitution reaction mechanism. Its success in improving student performance, engagement, and satisfaction underscore the importance of integrating digital innovation in chemistry education. In conclusion, the O-CHEM Makeup 5E VARK module is not just a tool, it's a revolution in how we approach teaching organic chemistry, especially substitution reaction mechanism. Imagine the possibilities when students not only understand but truly master the art of reaction mechanism. Thank you.